Well, good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Aqua Security. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes I'd like to review with everyone. First of all, we are recording our session today. So if you happen to miss any of our discussion, if you'd like to watch again later, or if you'd like to share with your team, you will be receiving a copy of our recording via email as soon as it becomes available shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. The first way is to use the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know from where in the world you are joining from today. Now, if you have specific questions, we do have a session or a section of our program dedicated to Q&A toward the end of our program. So send those questions into the Q&A and we'll be sure to do our best to fit them in. Additionally, if you jump to the handout section, you'll see there's an additional resource for you. So feel free to grab that while you're here. And we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. Ways to become eligible are to send in your chats, your questions, and to, of course, fill out our post-webinar survey pinned in the handouts. So today we are discussing REDIScovering HeadCrab, a technical analysis of a novel malware and the mind behind it. I'm joined today by Asaf Eitani, Senior Security Researcher at Aqua Security. And we're also joined today by Nitzan Yakov, Security Data Analyst at Aqua Security. So Nitzan and Asaf, thank you so much for joining us today. Asaf, would you like to take it from here and open up the program?
Yes, of course. Thank you very much. Welcome, everybody, and thank you all for joining us in this exciting webinar. We will demonstrate how HeadCrab attacked several hundred servers worldwide. We're going to take you through a journey of how we discovered the malware and how we were able to communicate with the attacker behind the malware and gain additional insights into the attack. So first things first, let's take a look at what we're going to do. So we're going to take a quick look around Redis, a quick introduction to understand what is our playing ground. And then we're going to tell you the story of HeadCrab, how we discovered it, and what his technical details are in the following section about the technical analysis. Then we're going to talk about the C2 infrastructure and the victims that we were able to detect. And then we're going to get to the really juicy part where we talk about the attacker conversations. We're able to extract additional insights from the attacker, and we're able to gain another binary to analyze. And then the following session is going to be, the following chapter is going to be about that binary, a little bit of a technical dive in. And to finish it off, we're going to talk about HeadCrab 2.0, a new threat that we discovered, a new version of the threat, which we recently published a blog about. So a little bit about ourselves. We're part of the Aqua Nautilus research team. Aqua is a cloud-native security company, which focus mostly on Linux operation system due to the nature of cloud-native environments. So most of our research is done on Linux environments. We're mostly focused around vulnerability research, threat research, malware analysis, and open source tools development. And let's take a look about ourselves. So I'm Asaf Eitani. As Cody mentioned, I'm a senior security researcher at Aqua Security, and I mostly do low-level Linux research as well as malware analysis. And in the past, I've done some incident response. And with me is Nitzan Yakov.
Hello, everyone. I'm Nitzan Yakov. I'm security data analyst at Aqua Security. As part of my work, I do threat research and data analysis in order to detect new attacks in the wild and investigate them. One of the tools we use that help us find those attacks is the honeypot. A honeypot is a common technique in which we use to attract attackers to implement their attacks on our honeypots. which provide us to find information about various things. As you can see, it allows to detect new methods and tools used by the attackers, which provide us information about immediate threats such as new malware, and it also provides us indication of malicious indicators associated with the attackers, such as IP addresses, domains, and hashes. It providing us deeper understanding on the threat landscape, focusing on attackers' TTPs, which allowing us to see the bigger picture. During our analysis process, we are using Aqua's open source solution, Tracy. Tracy is a runtime eBPF threat detection engine which monitors events on the machine. You can see here an illustration of a honeypot structure. As you can see, there are several applications that may consist certain vulnerability or misconfiguration, and on each one of them, Tracy is installed. Tracy is able to record the attack and identifies action performed by those attackers that later on analyzed by our team. As you can see, one of the applications here is Redis, and today we will focus on Redis. So what is Redis? Redis is a popular database solution. It supports master-slave cluster replication, which means that the master and slave can transfer data between one another. In order to decrease security issues, Redis added a new feature called protected mode, which is designed to prevent from Redis instances accepting connection from external hosts. But in case this feature is disabled, which means there is a misconfiguration in this instance, anonymous login is available, and an attacker can gain the ability to execute commands on our instance. Redis also boosts unique capabilities such as Redis Modules, which extends the server functionality. We mentioned Redis Modules, and Redis Modules are shared objects that, as we said, extends the server functionality by implementing Redis command with feature which is similar to what can be done inside the core itself. Redis module can be loaded into Redis at startup by using the Redis configuration file, or at runtime by using Redis command module load. Once Redis module is loaded, it's considered part of the Redis process itself and has access to all of its resources. So we took a glimpse about Redis and get familiar with it. And now let's introduce some security issue that discovered in 2018 by a security researcher. He found a technique in which he was able to abuse the slave of or replica of feature. Slave replica of are common commands in Redis. Replica of can be found in newer versions of Redis. And he presented this technique in a conference called Zero Nights. Let's see how it looks like. As you can see, we have the victim server. With the Redis server colored in red. Okay, sorry for that. The attacker scanned the network and identified our misconfigured Redis server. He connects to it anonymously and gained the ability to execute commands on our Redis server. He decided to turn our server into a slave and execute the slave of command and specify the IP address of the master server. Our Redis server becomes a replica of the master server and starts synchronized with it, expecting to receive data from it. However, in our scenario, the master server is malicious, and it sends malicious Redis module disguised as a data file. You can see that he sends the shared object HeadCrab. This shared object is saved to the temp directory, and the name of the module corresponds with the timestamp from the synchronization process. We will get into it on the next slide and see how the attacker used this fact. Now the attacker is able to load the module to the process and uses the module load command, and the HeadCrab malware is now part of the Redis process and has access to all of its resources. We saw how the attack works, and now let's take a look at how the attacks look like in the pickup file. So the attacker initiates the time Redis command and receives a time check. Then, as we mentioned, the attacker executes the slave of attack and receives OK. Then once again, the attacker executes the time Redis command and receives the time check after turning our server into a slave. So by now, the attacker receives a time range that includes inside it the timestamp from the synchronization process. As we mentioned, Redis, our master server is malicious, and it sends malicious Redis module disguised as a data file. The module name corresponds with the timestamp from the synchronization process, and the attacker used the time range he received earlier in order to brute force its loading. And you can see here number of attempts the attacker performed when he tried to guess the correct timestamp, and at the end, only one module successfully loads. So by now, the attacker gained the ability to execute command on our Redis server, and as you can see, he used it, and you can see that he executes the ID command and receives the answer from our machine. The attacker was able to load the malware, and now let's get familiar with the malware. So the special dish of the day is not a roasted chicken, despite how it might appear. HeadCrab is known from the computer game Half-Life, for those who know this computer game. In this game, HeadCrab is a monster which attacks humans and turns them to zombies. And this is essentially what the attacker performed on his attack. He targeted our host, infected it with a malware, and spread through the network in order to attack others. You might also wondering why we decided to name the malware HeadCrab, but the truth is we didn't. During our investigation, we came across this mini blog that the attacker had compiled along with the malware. And as you can see at the beginning, he introduced his tool as HeadCrab, and that's how we decided about this name. The attacker also mentioning that he initiated his attack in order to perform mining activities. So we understand that the main motivation is financial gain. The attacker also leave an email address and encourage those who find this mini blog to write to him. And if you take a closer look, you will be able to see that his name is Ice9J. So please remember this line. We will get into it later on. The mini blog also provides us indication to when the attacker started to initiate his attacks. We can see that in September 2021, he started to document his activity, and we presume that this is about the time he started to act and initiate his attacks. And now embrace yourself, because we are going to unveil the cherry on top. What was most intriguing about this mini blog is when we saw this line and we understood that the attacker took the trouble to mention us, Aqua Security. It occurred in December 2022 as a reply to a blog we had published a month earlier, and it was an amazing reveal to us as we understood the attacker is actually reading our blogs, and we got really excited to continue and investigate this malware and get more familiar with the attacker.
Thank you, Nitzan. So now let's take a look at the technical view of HeadCrab, now that we know a little bit about it. So what makes HeadCrab so special? First of all, HeadCrab is the first malware that we've seen custom Redis commands used as the C2 channel in order to communicate with the malware. We're going to delve into that a little bit deeper in the later slides. Another thing which is special in HeadCrab is the high operational security in comparison to other threats in the landscape. HeadCrab, it really puts in an effort to try to stay hidden and be operative as long as it can, and that as well we're going to see in the next few slides. And HeadCrab has over 50 advanced capabilities, ranging all the way from downloading file or running a command, all the way to loading a kernel module in a fileless manner. So in order to see the attack in a more structured way, we divided into 5 phases. So we're going to go through all of these phases: the infection, C2 channel, defense evasion, persistency, and lateral movement. So the first one we've already seen. This is the infection, and this is what Nitzan talked about, the slave of or replica of attack, which was revealed in the convention. And this is how HeadCrab performs his initial infection. The second phase is the C2 channel. As we mentioned, HeadCrab uses custom Redis commands in order to communicate with the malware over the Redis protocol. And you can see that in the first screenshot, where we see that he creates commands in the format of RDS and then another character in order to send commands to the malware. On the bottom side of the screen, you can see an example of the RDSR command being used to communicate with the encrypted manner with the malware. Then we get to the defense evasion phase. First of all, the malware overrides default Redis commands in order to disguise itself in the system. For example, we can see that it overrides monitor or module commands to try to hide itself. If you're running module list, you'll see all the loaded modules, and that would make HeadCrab appear, and you can discover that you're infected. Monitor is a command in Redis that is showing the history of Redis commands run on the server. So that is as well being overwritten. What's interesting is that two other commands are being overwritten, which is slave of and replica of, which, as you remember, was the infection method that the attacker got a hold of the server with. So this way, the attacker overwrites those commands, returning an invalid command specified to disable the opportunity to other attackers to infect that server with their own malware. Basically, HeadCrab wants to save this server to himself and doesn't want to share it with other attackers. So let's take a look at the attack graph now that we know a little bit more. As we said, the malware overrides command and registers new custom commands, and the attacker sends its commands to the malware through the RDS and another character command. And the first thing that we see HeadCrab is doing, as he mentioned in the mini blog, is run a crypto miner. XMRig is a common crypto miner, and it's dropped into memfd, which is a memory-backed directory, and then executed. So what is memfd? Memfd, along with others, is a memory-backed file system. This means that the files that are being saved there aren't actually saved into disk. They're run or accessed directly from memory. So memfd and devshem are two of those. The temp directory is a disk file system, but is being cleared on boot and often being ignored by these scanning solutions. The last technique is network buffer, and this is where HeadCrab receives the payloads from the network communication from the RDSR commands and actually executes them directly into memory without being saved. This is also a technique that HeadCrab employs in order to avoid these scanning solutions. Okay, so let's talk a little bit about the operation security. Let's see how HeadCrab managed to stay under the radar for over a year. So first of all, we have a couple of examples. Let's see the first one. Shell history hiding is something that HeadCrab is doing whenever he executes commands on the system. So whenever he executes a shell command, he attaches the hist file equal dev null as an environment variable, basically meaning that the history of that bash file won't be saved to the history file. The next technique is low clearing, and that's a technique that we see often, but not in the way that HeadCrab is doing that. HeadCrab is doing it a little bit differently because other threat actors are simply deleting logs, but that obviously triggers an alert most of the time. So HeadCrab is doing something pretty smart. Instead of deleting the logs, it translates them to size 0 bytes. That means that effectively the operation system clears them out and they are not being deleted. That would not trigger a normal alert on most systems. Another thing that we've seen HeadCrab is doing is hiding data in attributes. So as we mentioned a little bit with the memory-backed file, HeadCrab wants to avoid saving files to disk. So in order to save its configuration, he sets an attribute to some file in the file system, by that attaching the configuration to the metadata of the file. So if you're a researcher that's trying to investigate what's happening and see which files were created, you won't be able to see it. Another cool technique of HeadCrab is Lua file loading. Lua is a language that allows you tight memory control, so you can control the structure of the memory. This allows HeadCrab really good control over what he's doing and is able to load Lua scripts directly into the memory without them being saved. The next method is the dynamic loader. This is done in order to bypass runtime security products as well as whitelisting solutions. So what the HeadCrab is doing is executing a process through the dynamic loader. Instead of just executing this process, let's say for instance, xmrig, he's executing the dynamic loader and attaching the path to his desired process as an argument. That effectively creates a process in the name of the dynamic loader, but the content of that process would be our malware. The next stage is the file timestamping. Whenever HeadCrab does change files, let's say for configuration files or service files that we're going to see next on, is modifying their change time back to their original time in order to avoid being detected by security researchers that try to find change files or new files. Another cool thing that we've seen HeadCrab is doing is using the iNotify feature of Linux in order to know if somebody is trying to find him. So iNotify is a system or feature that allows you to put, let's say, an alert on certain files and get an alert whenever somebody is accessing those files. HeadCrab is putting those alerts on procstat and on devpts in order to know if somebody is trying to find him. So the procstat is used in order to check if anybody is trying to, let's say, run top or see the process list in order to find a process that consumes a lot of CPU, like xmrig. And the devpts is used in order to know if somebody logged in using SSH to the machine. In those cases, HeadCrab stops his mining activities in order to stay hidden. The last thing that we see in the terms of defense evasion is a clever persistency planting that HeadCrab is doing. So HeadCrab is inserting configuration into the Redis configuration file, stating that he needs to load his own malware whenever the server restarts. This is done with the load module command. But it's not just adding that to the configuration. It's adding a lot of spaces before and after in order to hide this command from the unsuspecting eyes of a technician or a security researcher. So for example, you can see in the bottom screenshot, I know that you can't read it, but it doesn't matter. You can see on the left side of the screen, you have the configuration, and all the way in the right side of the screen, you can see that we have the command, which if you look at with the normal editors like Vim or Nano, you won't be able to see it.
Let's see some of his persistency capabilities. As Asaf mentioned, the attacker uses the module autoloading as a persistency technique. The attacker also mentioning that he created a credential stealing service that does use with the init script as a restore script. And we will show you the service on the next slide, so stay tuned. The attacker also possesses lateral movement capabilities. During our investigation, we came across the server that attacked us, and we started to investigate it and in order to find its origin. And we found out that this server belonged to a security company, and we found it a bit odd because why would a security company start to attack other servers in the wild? We decided to dig a little bit deeper, and we discovered that the attacker initially attacked this server, turning it into an attacking server, and then use it in order to attack other, us included. As you can see, the attacker attacked servers worldwide, turning them into attacking servers using his pivoting and tunneling capabilities, and basically creates a botnet, which makes it even harder to find its origin. Let's recap what we have seen by now. So we talked about the infection method, how the attacker abuses the slaveful replica feature in order to infect our Redis instance. Then we continue to talk about the C2 channel. The attacker is actually creating custom commands that allow him to communicate with the malware and initiate actions on our instance. Then we show you numerous of defensive agent techniques, and this is the highlight of HeadCrab. We continue to talk about some persistency technique, and lastly, we talk about the lateral movement capabilities the attacker possesses. What made us wonder how many Redis instances were infected due to this attack and had become attacking servers. We started to think of a unique method in order to detect those infections in the Redis servers. And since we know that the attacker creates custom commands in order to communicate with the malware, we thought that we will be able to use the common Redis command, which prints all the available commands on a specific Redis instance. And in case those RDS commands will appear in the certain instance, we will be able to indicate this server as infected. You can see here an illustration of an infected Redis server. As you can see, we executed a command which prints all the available commands on the instance. At the beginning, you could see the default command like slaveoff and time. And at the end, you can see the RDS custom command like RDSS, RDSR, etc., which indicate that the server was infected. Using this method, we scanned the network in order to find Redis servers that were infected, and we revealed that 1,200 servers were compromised due to this attack. And you can see that the servers are located worldwide. The attacker is not targeting specific country or specific region, which emphasizes our assumption that the attacker initiated those attacks for financial gain. During our investigation, some of the servers found belonged to different companies, and we informed them that they were attacked. We showed you some of the attacker's techniques, and now let's get familiar with the attacker himself. Not long ago, we mentioned that the attacker has left an email address in the mini-blog, remember? We couldn't forget about it either, and we decided to write to him and test our humid's ability. And surprisingly, the attacker actually answered us. And on our first conversation with the attacker telling us that we were the first one to write to this email address. And we found it a bit odd because we know that the attacker started to attack in September 2021, and we discovered about the attack about a year later. And this extended timeline emphasizes that we might be the first one to discover about this attack.
So we didn't want to waste time and asked him what his name was. He didn't tell us his full name, of course, but he said that his name was Ice9. So of course we've seen that string before. This was in his email and other places too. So we tried to find out what this name means. And first of all, we stumbled across this song. So this is Ice9 by Joe Satriani, or maybe Ice9J as in the email. But as we dug a little bit deeper, we found another reference to that in a blog. In a Wikipedia about a Person of Interest TV series. In that series, Ice9 or Ice9.exe is the world's most lethal virus developed by the Department of Defense.
That's a virus. My God. Ice9.
Outages global as it stretched into its second day. Financial markets plunged, sending the world's economy into turmoil. The catastrophic malware dubbed the Ice9 virus by security experts continues to proliferate as systems across the world are experiencing its effects.
Okay, so as you can imagine, HeadCrab is not taking over the world just yet, but is trying to one Redis server at a time.
Outages global as it stretched into its...
We continue our conversation with the attacker, and we wanted to ask him if he is related to a known attacking group. And we decided, like Team TNT, for example, and we decided to mention them. And the attacker revealed some interesting information about Team TNT. According to him, Team TNT uses the same credential for all of their hacked system, and making it easy for him to use his credential stealer tool in order to take control over those resources. This is a brilliant move by the attacker, as he uses his credential stealer tool in order to take control over others' resources and use it for his own good. The attacker also mentioning that he developed a new mode that he called semi-fileless. According to him, he is preventing creating files on disk and only allow it before reboot or when power off when process ID is equal to 1. And this is exactly like getting on a train before it leaves the station. The attacker is able to leave a mark on the compromised machine and able to getting back to it without being discovered. The attacker also mentioned that he is not targeting Redis in particular, but also targeting Postgres, Nginx, SSH, and even Docker, which emphasize how widespread the attack is. Funny or not, but even our attacker follows some rules, and he sent us this set of rules that he follows. And in the first rule, the attacker mentioned that he concerned from the high performance rates on the compromised machine, but he actually just worried that his mining activity will be discovered as it increases the performance rates as well. And the second rule, the attacker mentioned that he strived to eliminate competitors in order to maintain control of the machine, and does so by removing, terminate previous campaigns. In the third rule, as we mentioned in the technical analysis part, the attacker is closing the backdoor by removing the slave of or replica of commands, and by that assure from future infection to appear. By now, we understand that the attacker strives to hide himself and conceal his mining activity, and as we mentioned, he uses iNotify in order to do so. So whenever he finds out that if someone connects to the machine, he stops the mining activity, which allows him to conceal himself and hide his activity. Our relationship with the attacker had tightened, and it felt like it was the right time to send us a present. How lucky are we, right? And he decided to send us his credential stealer tool along with detailed instructions on how to use it. And you can see here an example of the credential stealer tool. He sent us a screenshot. And now, as promised, let's introduce you with the service.
Thank you, Nitzan. So now that we got a present from the attacker, it would be rude not to analyze it, of course. So let's take a look at what that service is doing. So for those of you who aren't familiar with the Half-Life games, this is G-Man, a mysterious figure from the game. And this is not a screenshot from the game itself. This is actually a screenshot from our debugger connected to the service. Whenever the service notices that a debugger was attached to it, it first of all dumps this ASCII art into the debugger and then kills the debugger. The service also prevents access to malicious files using the FA notify feature of Linux. This feature allows a user to register certain paths to control their request to. So, for example, he has all of his malicious files and paths that he uses, and if somebody else tries to access them, HeadCrab simply denies them. The service simply denies them. Then he deploys multiple hooks using multiple methods, starting off with ptrace, which is really common and easy to block and easy to detect, but is moving one method at a time, going all the way up to direct memory access and manipulation in order to insert these hooks onto the other services. And he's hooking authentication and connection function on SSHD, FTPD, MailD, and also contains some references to SQLD, although we haven't seen it in the version that we investigated. Another cool thing that the service is doing is he re-inject the main HeadCrab Redis module into the server. He's doing that by scanning the localhost for any Redis ports, and if it was found, he connects to it and uses the module load in order to reload the malware to the memory. This indicates the tight connection between the HeadCrab malware as the Redis module and this service, as they need to coexist in the same machine. You can also see that they are pretty similar. They're similar in 87% and 84% in functions. So that means that they share a lot of code, mostly due to that the service is doing pretty much everything that the HeadCrab SO is doing as well. So let's take a look at our attack graph. I know that you missed it. So now that we know a little bit more about the attack, let's take a look at it in the graph. We can see that the HeadCrab drops and installs the service. By the way, its name is ICE9J, which hooks the other services in order to try to steal credentials. Then HeadCrab is using the FA notify in order to block access to any of its files, and finally re-inject headcrab.so. So this was pretty cool, and we thought that we were done, but then
several months later,
we found HeadCrab 2.0. So of course, the first thing that we're gonna do is take a look at the mini blog, of course. So let's see what happened. We can see that after we published our first blog about HeadCrab, he referenced that and says that he likes the futuristic HeadCrab picture. He also mentions some information regarding the technical details that we didn't describe in the blog. And also he asked if we can catch his service. Of course we can, but we don't need to because he already sent it to us before even writing that message. Then on March, we can see that he's attaching a YouTube video, which was really curious to us, and we were wondering what it was. And we were surprised when we opened it up, and it was a weekly CTI video of Daniel Lori about our blog about HeadCrab. So we can see HeadCrab is also interacting with other security researchers regarding his malware. Then on April, we can see that HeadCrab is, or ICE9, is mentioning that custom commands are gone with the wind, as are most of the Tracy alerts. We're going to touch on the custom commands in a bit, but let's talk a little bit about Tracy alerts. This indicates, as you remember, Tracy is our open source project, a runtime security tool, and this indicates that the attacker is specifically testing his tools against our Tracy, our project. Here is referencing to our open source signatures, but of course, we have a lot of proprietary signatures that is not avoiding as well. He has some plans for the future in terms of how to try to avoid signatures, and he also have another reference to Daniel, and it tries to explain why he's doing the things that he's doing. So let's talk a little bit about the Redis hooks. So this is the Redis command structure in Redis, and as you can see, it has the Redis command proc attribute. This is a function pointer to the function that will run the command. So what HeadCrab is doing is replacing that pointer with his own function in order to hook default commands. As you remember, when you overwrite a default command, this is how he's doing that. As you can see, this is a pretty simple operation of switching the pointers and saving the original one. Also in HeadCrab 2.0, we've seen that HeadCrab is running the original command if the user that's trying to run the command is not HeadCrab and is trying to avoid it. So he talked about the fact that custom commands are gone with the wind. So how does HeadCrab control his malware? So he switched it up, and instead of creating custom commands, he's communicating with the malware with the help of the mget command, which is the default command on Redis. He's doing so in the following manner. This is a normal execution of the mget command, simply asking for a value to a key and getting that value back. But when HeadCrab talks with it, it seems like something like this. So first of all is specifying a special string, which is constructed for each instance, special string, to identify itself as the attacker. Then an encryption key is being sent to the attacker, and encryption keys are being exchanged, following by encryption communication with the malware. This is done in order to avoid being detected by any IDS solution or signatures. Okay, so let's get back to our attack graph. This is the last time, I promise, don't worry. So this attack graph is a little bit different. If you notice, you can notice that the rogue server doesn't send the HeadCrab malware, it sends the loader instead. And this is done in HeadCrab 2.0 in order to avoid getting HeadCrab SO saved into the temp directory. So what it's doing is sending a loader file instead, which is saved. It's a simple and small payload. It's saved to the temp directory and being loaded in the same manner that we've seen before. But then the HeadCrab SO is being sent to that loader, saved to memfd as the shared overwrite file, and then being loaded into the memory, allowing the attacker to communicate with it with the mget command after he overwrites the default commands. So we've seen the overwriting and then the mget command being used, of course, to run a crypto miner in the same manner. Then everything else is as usual, as we've seen with the SSH stealing service, the reinjection of HeadCrab, fnotify, and everything else. So if you want to take a screenshot, this is the full attack of HeadCrab 2.0. We have that as well in our recent blog post as a GIF of all of the stages of this attack. So as we mentioned, custom commands are gone with the wind. So how we're gonna find new victims? We also have a problem that the new version runs the original functions when we try to interact with the Redis server. So what do? So let's take a look at our one of the commands that been hooked and the new command that HeadCrab implants. And if you notice, you can notice that if we try to rewrite or set the dir or db file name of the server, we get an instant OK, which is not a regular behavior for a Redis server. So we had an idea. Let's try to change the dir key to a non-existing path and see if which servers return OK and which server return an error. So this is how it looks like. We can see that the clean server returns an error that no such file or directory exists, of course, because we just mentioned some random hash that we created. And on infected host, we can see that HeadCrab returns an OK. This led us to the discovery of another 1,100 new infected servers worldwide, as well as we've seen in the first version, they are scattered all over the world, indicating that HeadCrab is mostly focused around financial gains and not really doesn't really care about politics or geography. Okay, so let's conclude this talk, and then we're gonna move on to Q&A. First of all, we can see that HeadCrab or ICE9 it has a deep understanding of Redis framework and how to use it in order to fit in with normal behavior. We're able to engage with Redis team in order to try to find solution to how those kind of attack can be solved in the future. We also saw how we were able to find issues in the malware in order to detect victims, which is a really powerful technique. And 2 tips before we end this session is if you're using Redis servers, use protected mode. It will save you from HeadCrab. And Tracy and Aqua CNDR can help detect those threats along with other runtime solutions. Thank you, everybody. If you want to check out our blogs, those are the links. We also have our social media and the blog links in the QR code, which you can scan, as well as our Twitter and everything else.
All right. Well, Asaf and Nitzan, thank y'all so much. We have received 1 question so far, so I will just give one final call out to anyone who has any questions. Go ahead and submit those to the Q&A. We've got time here to take a look at them. So our first question reads, have there been any observed patterns in the industries or geographic regions targeted by HeadCrab, and what implications does this have for affected organizations?
Okay, so as we've seen in the first version as well as the second version, HeadCrab doesn't really care about geography or anything else. He's more focused about the financial gain. So he's trying to get as much money as he can. And what implication does it have on the organization? HeadCrab has really unique capabilities which allow him to pivot inside networks and steal credentials. So if an organization was infected with HeadCrab, they should consider opening an investigation, incident response, and try to see where that threat was going and if it tried or succeeded into hacking or infecting other servers as well.
All right, and it looks like we have a question from John, and John just asked if we can post some links here. So I am going to ask you guys to compile a couple of the links that you've talked about and potentially send those out to our registrants after the webinar. If that's all right with you guys?
Sure.
Yeah, for sure. I think we can also publish it now.
Oh, yes. It looks like Joe has started posting some of those links there in the chat. So John, take a look at the chat. Some of those links are going to be there. Perfect. We received another question here from Daryl. How often do you see instruments such as this that indicate origins from the DoD?
Well, we think it wasn't really a virus from the defense of the Department of Defense, of course. I think this was a way of the attacker just simply trying to be funny or using his favorite TV or something, a TV show or something like that, to be creative with the naming of the malware and itself.
Perfect. Makes sense. So we are out of questions at this point. I'll put out one more call while I read out a couple of our closing remarks. So last call for questions, everyone. In the meantime, I will remind you that our session today was recorded, and you will be receiving an email with a link to access the on-demand recording. You'll also find the recording living on the Cloud Native Now website. Just visit cloudnativenow.com/webinars, and it will be in the on-demand section. Additionally, I will be reaching out to 2 of our most engaged attendees to win a $50 Amazon gift card. So thank you so much for your chats, for your questions. And if you would still like to become eligible, there is the link to the post-webinar survey pinned to the top of the chat, as well as there in the handout section. So taking one last look, we got a couple more questions. So let's take them. How do we enforce persistent logging?
Okay, so it depends on what your logging solution is. With Aqua, we have either Tracy, which is the open source solution, which can be used in order to save logs whenever you want, and then maybe upload them somewhere. And Aqua CNDR will save those attempts and those actions, malicious actions, into the database, and you will be able to see them in the product itself, in the screens.
Perfect. We've got another question here. I'll put it up on the screen for us. How is the HeadCrab malware continuing to evolve in both virality and efficacy? How does it affect detection and remediation?
So we've seen an example to that with the custom commands. This is a switch that HeadCrab has done. We assume after our blog post, he probably understood that this is the way that we found the victims. And as we've seen, he tries to make it harder for us to find victims, making our lives harder to find it itself within the system, trying to add more operation security. As we've seen, this is one of the most powerful points of the HeadCrab malware. So we predict that this side would continue to evolve, and as always, we're gonna monitor for that and add any malicious behaviors that we've seen into our CNDR and other behavioral detections.
It looks like we've got one final question, and they just ask if you have any predictions for AI, quantum, or really anything else.
Not in the sense of HeadCrab, I think, but we do use AI in our work in researching, both in malware analysis as well as threat research. And we try to incorporate that into our work in order to become more productive. So this is as well something that we're doing nowadays.
All right, I've gone and put our next question up on the screen. What are some key recommendations for threat modeling within the OSSF metrics for AI?
Well, I don't think that really has something to do with HeadCrab. I'm not sure about that, but we can try to help, but that's not really the topic that we're discussing here.
All right, perfect, understood. That is the last of our questions. So I did want to give each of you the opportunity to leave us with any final remarks before we officially take things off the air. So Nitsan, Asaf, anything top of mind?
Thank you for having us. Thank you all for coming. Thank you, Nitsan.
Thank you, Asaf.
And we hope that you enjoyed it.
Wonderful. Well, thank you both. We really appreciate you joining us here on Techstrong Learning, and we just really appreciate the expertise that you brought to the table today. I know this is a big topic, and a lot of people seem to have a lot of interest here in following HeadCrab as it expands or gets taken down, either way. So I would like to thank both of our speakers today, Nitsan and Asaf. I'd like to thank Aqua Security for sponsoring our program today. And to our audience, thank you so much for being here with us. We appreciate your time, and we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect.